in continuation with the electromagnetic induction chapter, let us discuss AC generator. AC generator. Now, what is generator? What is AC generator? What is the main principle of AC generator? So that we will study now. See, the method of producing a flux change is the main principle of the AC generator, and it converts mechanical energy into electrical energy. See here, mechanical energy to electrical energy means mechanical energy, using mechanical energy we have to convert this into electrical energy. But here the same process is taking place. Now, what it consists? The AC generator that consists of these two magnets, north and south pole, and in between the magnet a coil is there. This is coil and this is the axle of the coil, and this rotates like this. Now this coil is also called armature. The word armature. Okay, this is called armature. Now this armature, the two ends of this coil, they are connected to the alternating EMF through slip rings, carbon brushes and this spring. Right? So these two are the slip rings and these are the carbon brushes, and this is connected to the alternating EMF. Okay? So once again, here I repeat it. These two are the two magnets having north and south pole, and in between the magnets the coil is there of rectangular shape. Now this coil, the two ends of the coils are connected to the slip rings and carbon brushes through this alternating EMF. This is connected to the alternating EMF through carbon brushes and slip rings. Okay, this is the main construction of this AC generator. Now, what is the process? When this coil starts to rotate, the coil is rotated, always the coil is rotated perpendicular to the magnetic field direction. So field direction is this one, and this rotates always perpendicularly. Suppose this is the direction of the field, and if this is the direction of the field, the coil rotates like this, that perpendicularly it rotates. So rotation of the coil is like this. Now as the coil rotates, there is a change in flux. Whenever there is a change in flux, EMF is induced. This process we know. Here also the same process that is taking place here. While rotating this coil, there is a change in the magnetic flux. Okay, and we have studied that change in the magnetic flux phi p is equal to B A cos theta. Now theta is the angle between B and A. Here one method to induce the EMF here is the orientation of the change in the orientation of the loop. How to change the orientation of the loop? That means the change in the area, effective area of the loop by rotating this. Okay. Now when you rotate this one, the change in the area of the loop can be considered as A cos theta. Okay. So where theta is equal to, when this coil is rotated with a constant speed with the angular speed omega, then this theta is equal to omega into t. Okay, so we have to consider the time for different time. T is equal to 0, then t is equal to t by 4, then t is equal to t by 2. Like that we have to consider the time, and we have to plot the graph here. So theta is equal to omega t when this coil starts to rotate with a constant angular speed omega. Theta is equal to omega t, where theta is the angle between the magnetic field vector B and area vector A. As a result, the effective area of the coil exposed to the magnetic field lines changes with time. Therefore, the flux change phi B is equal to B into A into cos theta. Now, what you have to do? How to calculate the induced EMF? From Faraday's law, of induction, we have studied that E is equal to d phi divided by dt, d phi B divided by dt. If there are n number of turns, this is equal to n into d phi B divided by dt. Now we have to substitute the value of phi B as BA cos theta. So this is equal to n into d divided by dt of BA cos theta. Now take this BA outside here. So this is n A B into d by dt of cos theta. Now I will substitute this value of theta as omega into t. So this is equal to n A B d by dt of cos of omega t. Right? Just I have substituted the value of phi b and theta. So finally we have got this one as E is equal to n A B d by dt of cos omega t. Now we have to do this part, d by dt of cos omega t, that we have to. Thus, instantaneous value of EMF we have got here is instantaneous value of EMF is E is equal to NAB d by dt of cos omega t is omega sin omega t. Therefore, this is NAB omega sin omega t. NAB omega and sin omega t is the differentiation of cos omega t. This part is over. Now, this part NAB omega is the maximum value varies between if sin omega t is equal to plus or minus 1. Okay, so this is having the maximum value. That means we will got the maximum value of this between, if you plot a graph of, I will show you this one. If you plot a graph of, this is induced EMF versus time for different angle of rotation. This is for 0 and next for t by 4, next t by 2, like that. That is 0 for 90 degree, then 180 degree, next 270 degree, then 360 degree, like that you have to continue. So when the armature rotates, so at time t is equal to 0, then the induced EMF starts to increase. So it reaches maximum and again it starts to decrease. Then here the same process continues like this. It goes like this. Okay, so at theta is equal to 90 degree and at theta is equal to 270 degree, we will get a maximum value. Extreme values we will get this for theta is equal to 90 degree and theta is equal to 270 degree. Theta is equal to 90 degree in the positive x direction and theta is equal to 270 degree in the negative direction. So we will get these cycles, continuous cycle, that is there is a change in the cycle, positive, negative, alternative. Therefore, the current, direction of the current changes periodically with time. Therefore, it is called alternating current. See here, E is equal to NAB omega sin omega t, and I will replace this NAB omega as E naught. So we can write this one as E is equal to E naught sin omega t, where E naught is equal to NAB omega. So this E is equal to E naught sin omega t is the expression that we get here. So previous year, that is last year, we have studied in case of oscillation and waves. There we have studied the displacement expression as y is equal to A naught sin omega t, like that, A naught cos omega t. The same expression here we will get this one as E is equal to E naught sin omega t. So the method of producing an induced EMF using the armature, the rotation of the armature, that is the main principle behind this AC generator. Okay. E is here, E is equal to E naught sin omega t. So as we know that when this rotates, that omega becomes, this is equal to 2 pi mu. So this omega is equal to 2 pi mu, and we replace this as E is equal to E naught sin omega becomes 2 pi mu into T. So this is the main expression that we get in the case of AC generator. Okay. So here the detailed part of this graph, how to draw that, I will show you now. This is the diagram of an alternating EMF is generated by a loop of wire rotating in a magnetic field. So different stages are given here, and along with that the graph is also shown here. So in the stage 1, the plane of the armature is perpendicular to the magnetic field. Observe the diagram, the plane of the armature is perpendicular to the magnetic field. See here, this is the armature P, Q, R, S. This armature is here, and N and S are the north and south pole of the magnet. In between the armature is there. The first stage is the plane of the armature is perpendicular to the magnetic field. See, armature is perpendicular to this field here. And in the second one, when the armature rotates through 90 degree, the plane of the armature is parallel to the magnetic field. When this armature is rotated, so like that, so just rotate this one. If this armature is rotated and through 90 degree, it comes like this. In between these two magnets, the armature is like this. Now in the stage 3, that is here 0, observe this one here, this is 0, and this is rotated through 90 degree here. And third one, the armature after rotation of 180 degree. So again this is rotated inside like this. And the diagram, imagine the diagram how it rotates. The rotation of 180 degree here. So here 180 degree, that is the 0, 90 degree, 180 degree, the time becomes here t is equal to 0, this along this x-axis time, and along the y-axis induced EMF, it is the time for 0, and next 1/4 t by 4 second, it is rotated through 90 degree, and next t by 2 second, it is rotated to again 180 degree, next 270 degree, and 360 degree. Total rotation is given here. In the stage 4, armature after rotation of 270 degree. So this is the rotation of 270 degree, that is 3t divided by 4. Lastly, you have to rotate this for 360 degree. That is the direction of the magnetic field is shown here. This is the direction of the magnetic field. Now the armature after rotation through 360 degree. So once you observe this one, here the direction of the current changes periodically. See here, the first it starts from 0, the direction of the current is like this, in the positive direction. Next again it changes to negative direction. So this continues. It looks like an alternating current. Therefore the current is called alternating current. Okay. Apart from AC generator, other types of generators are there. They are hydroelectric generators, thermal generators and nuclear power generators. Now the name itself indicates hydroelectric generator. Hydro means water. Thermal means heat. Nuclear power generator means the fuel used here is nuclear. Now in case of hydroelectric generator, water is falling from a very high height from the dam to produce the rotation of the armature. Whereas in case of thermal generator, thermal means heat, the steam is produced. How the steam is produced? Using the different source or coal, the steam is produced and that steam is used to rotate the armature, and then the generation of the electricity is possible. In case of nuclear power, instead of coal, nuclear fuel is used to generate the electricity. Okay, so these are all the different types of generators apart from AC generator.
Modern day generators produce electric power as high as 500 megawatt. That is, one can light up 5 million 100-watt bulbs. In most generators, the coils are held stationary, whereas the electromagnets which are rotated. The frequency of rotation is 50 Hz in India, whereas in other countries such as USA, it is 60 Hz. So these are all about the generators.
Let us solve this problem. In this problem, Kamala pedals a stationary bicycle. The pedals of the bicycle are attached to 100-turn coil of area 0.10 meter square. The coil rotates at half a revolution per second and it is placed in a uniform magnetic field of 0.01 Tesla perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? See here, Kamala pedals a stationary bicycle and the pedals of the bicycle are attached to 100 turns coil. The number of turns in the coil is 100. N is equal to 100. The area of the coil is 0.10 meter square. A is equal to 0.1 meter square. The coil rotates at half a revolution per second and it is placed in a uniform magnetic field of 0.01 Tesla. That means B is equal to 0.01 perpendicular to the axis of rotation of the coil. The magnetic field is perpendicular to the axis of rotation. Now here we have to calculate the maximum voltage generated in the coil. So you know the formula. According to the formula, E0 is equal to NBA omega. So omega is equal to 2 pi nu. Therefore E0 is equal to NBA 2 pi. Nu value we have to substitute. N value is 100, B is 0.01, A is 0.1, 2 into pi value 3.142 into the frequency value nu is equal to 0.5. So just multiplication, you do the calculation and you will get the answer as 0.314 volt. Here 100 into 0.01 into 0.1 into 0.5 into 2. 0.5 into 2 is 1. 1 into 0.1 is 0.1 and 100 into 0.01 is 1. So 0.1 remains. 0.1 into 3.142, it is 0.314 volt. So the answer is 0.314 volt.
Let us solve this problem Read the problem first.
The problem is a circular coil of radius 8 cm and 20 turns is rotated about a vertical diameter with an angular speed of 50 radians per second in a uniform horizontal magnetic field of magnitude 3 into 10 raised to minus 2 Tesla. Obtain the maximum and average EMF induced in the coil. Then, if the coil forms a closed loop of resistance 10 ohm, calculate the maximum value of current in the coil and calculate the average power loss due to Joule heating. Where does the power come from? So, this is the problem. So, let us write the given quantity. A circular coil of radius 8 cm. That means R is equal to 8 centimeter. So this is equal to 8 into 10 raised to minus 2 meter. And 20 turns, it has 20 turns. Number of turns is equal to 20. It is rotated about a vertical diameter with an angular speed of 50 radian per second. Angular speed is omega. It is 50 radian per second in a uniform horizontal magnetic field of magnitude 3 into 10 raised to minus 2 Tesla. That is magnetic field B is equal to 3 into 10 raised to minus 2 Tesla. That means a circular coil is rotated vertically in a uniform magnetic field. See here, the diagram, this is uniform magnetic field, horizontal magnetic field, and a circular coil, this is rotated vertically, means like this, it is rotated vertically in a uniform magnetic field. This means this is the center and the radius is this one, that radius is 8 into 10 raised to minus 2 meter and magnetic field value is 3 into 10 raised to minus 2 Tesla. So this is the given quantity. Now, obtain the maximum and average EMF induced in the coil. So, what is the average EMF? EMF average. What is the average EMF induced in the coil? And the next part is, if the coil forms a closed loop of resistance 10 ohm, the resistance of the coil is 10 ohm, R is equal to 10 ohm. Then calculate the maximum value of current in the coil and also calculate the power loss. Maximum value of current means I maximum you have to calculate as well as power loss. Loss in the power also you have to calculate. So one by one let us calculate this one. See here, obtain the maximum and average EMF induced. You know the formula, EMF induced is equal to E is equal to E naught sin omega t, or you know that E is equal to NBA omega sin omega t. This formula you know. Now if you replace E naught as this NBA omega, E naught is equal to NBA omega. Let us calculate the value of E naught first by substituting all the given quantities. N is equal to 20 turns into the value of B is 3 into 10 raised to minus 2 Tesla, and area is not given. Instead of area, radius is given. Radius is 8 centimeter, that means 8 into 10 raised to minus 2 meter. Therefore, the area is pi r square. So, this is equal to pi means 3.142 into r is 8 into 10 raised to minus 2 whole square, pi r square. And A is over now. Then omega value is 50 radians per second into 50. So you have to calculate this value. That is 20 into 3. It is 60 into, this is 50 into 3.142 into 8 square. 8 square is 8 is 64 into 10 raised to minus 2 square is 10 raised to minus 4. 5s are 30 into 10 raised to 2, 0 0 is there, into 10 raised to 2 into 3.142 into 64 into 10 raised to minus 4. So 10 raised to plus 2, 10 raised to minus 4 is 10 raised to minus 2. So, and again 30 is there. So 10 raised to 3 into 10 raised to 3 into 10 raised to minus 4 is 10 raised to minus 1 remains 3 into 3.142 into 64 into 10 raised to minus 1. So after calculating this value, just calculate this one and find out the value of this one. So I will directly write the value of this. 1 minute. Okay, this value becomes 0.603 volt. E naught is equal to 0.603 volt. Now what they have asked? They have asked obtain the maximum and average EMF. So average EMF is equal to, so E is equal to E naught sin omega t. That means E average EMF is equal to E naught sin omega t, like this. So always you know that average value of sin omega t, whether it is sin omega t or cos omega t, the average value is 0. Therefore the total value is 0. Average value of EMF induced in the coil is 0. Okay, so this is the first part. First part is over now. Next is, if the coil forms a closed loop of resistance 10 ohm, calculate the maximum value of the current in the coil. So calculate the maximum value. I will write this one. Maximum value of current. Current in the coil I maximum is equal to E maximum divided by R. E divided by R. E maximum just now have calculated. The E maximum value is 0.603 volt divided by R value. R value resistance value is 10 ohm. 0.603 divided by 10. So this is equal to 0.0603. That is current is ampere. I maximum is 0.0603 ampere. So this is the second part. Okay. So what is the next part? Calculate the average power loss due to the Joule heating. Power loss. You know the formula of power loss, P is equal. Next part we have to calculate the average power loss due to Joule heating. So they have asked the average power loss. Average power loss is equal to power loss average is equal to ERMS into IRMS. This RMS root mean square velocity. This RMS value you can study this. You will study this in the AC chapter. ERMS into IRMS, or you can write this one as I square RMS into R. Now you substitute this value. ERMS is equal to average value of this one is E naught sin omega t into IRMS is E naught divided by R sin omega t. So average value. Now E naught into E naught square, sin omega t, sin square omega t. So it is E naught square sin square omega t divided by R. Okay. So E naught square sin square omega t divided by R. Now you just substitute the value. You know the value of E naught square and the sin square, average value of the sin square omega t is half. So therefore the formula becomes, it is E naught square divided by 2R, because this is Average value of sin square omega t is half. Therefore, half E naught square divided by R. Substitute the value. E naught square is 0.603 whole square divided by 2 into R value is 10. So, after solving this one, we will get this one as 0.018 watt. So 0.018 watt, this is the answer for the average power. So these three part is over now. That is, first part is calculation of the average EMF. Next part is calculation of the maximum value of the current, and third part is the average power loss. The power loss in terms of watt is 0.018 watt. Okay, so this part, RMS part, and this average sin omega t, sin square omega t, these values, this you will study in the next chapter. Just you take on the formula as power average is equal to E naught square divided by 2R. Clear? So in the next video we will discuss the further part. Thank you.